Let's take a look at the following linear programming application. You have $100,000 to invest over three types of investment vehicles. The current bond yield is 3%, a popular index fund is projecting a 12% return, and gold is expected to rise 10%. To play it safe, you want to keep no more than $20,000 in the stock market and at least 4 times as much in bonds as in gold. If the projected returns are accurate for each investment, how much should you allocate for each investment vehicle in order to achieve maximum profit? Okay, so that's a mouthful, and we got a lot of information to digest here. So let's go ahead and get started. This is actually a linear programming application. So let's go ahead and define a few variables. So we're going to let x equal the amount of money. We're going to let the amount of money invested in bonds. So x is going to equal the amount of money invested in bonds, which gives you a 3% yield. We're going to let y equal the amount of money invested in gold. Now, if you recall, we have 3 investment vehicles. We have bonds, we have gold, and we have an index fund. We'll get to the index fund in a second, but for now, we're going to be labeling these 2 variables as bonds and gold, and each have their respective return, their respective yields. So we want to label our third variable z as a total return. This is actually what we're looking for. We want to maximize this. This is called, in investment terms, ROI. It's called return on interest. All right. And for our third investment vehicle, we have what's called an index fund. This is where a group of fund managers actually take your funds, and for a fee, they plug it into the stock market and they invest it in different stock market vehicles. So we're going to get a 12% projected return on this. So we're going to need an expression that's going to give us the amount invested in an index fund. Well, we have $100,000 total to invest. We're investing X amount in bonds and Y amount in gold. So we can say that the amount invested in our index fund, in our stock market, is going to be $100,000 minus the total amount invested in bonds and gold. So minus X plus Y. And this is going to equal the amount of money invested in the index fund. In the index fund. And we're projected to get a 12% yield. So we're going to get a 12% return on our interest here. Okay, so we have our 3 investment vehicles, X, Y, and this expression. We have Z as our return on interest, which is what we want to maximize. So basically, this is actually what we're going to want to deal with. We're going to solve for. So we're going to have our equation Z equals our total return. So our total return is going to consist of the return on bonds plus the return on gold plus the return on the index fund. So let's start with the return on bonds. The return on bonds is going to be 3% times the amount invested, which is X. So this is going to give us 0.03X plus the amount in the return on gold. So our return on our gold investment is going to be 10% times the amount invested, which is Y. So we're going to have 0.1Y. And plus, our total return is going to be the return on bonds plus the return on gold plus the return on our index fund. This expression is for the amount, it defines the amount invested in our index fund. So we're going to get 12% times this expression. So 0.12 times the following, 100,000 minus X plus Y, because this is our expression that defines the amount invested in our index fund. So let's go ahead and we can simplify this side. So let's rewrite 0.03X plus 0.1Y. Go ahead and rewrite 0.12 and simplify inside the parentheses. We can rewrite 100,000. And what we're going to do is we're going to distribute this minus sign into the parentheses here. So we have minus X minus Y. Okay, we can go ahead and rewrite this. 0.03x plus 0.1y. Let's go ahead and distribute this 0.12 into the parentheses. So 0.12 times 100,000 is 12,000. 12,000 is 12% of 100,000. 0.12 times a minus x is minus 0.12x. 0.12 times a minus y is minus 0.12y. Okay, and we have some terms here that we can combine, so let's combine like terms. We have a 0.03x and a minus a 0.12x. And this is going to give us, well, let's start with 12,000 first. This is going to be actually the only positive term, so let's put it out first, put it out front. We can mark through these as we go. Now let's go with the x. We're going to have a minus 0.09x, and minus, we have two y terms left, 0.1y and minus 0.12y, so we're going to have a minus 0.02y. Okay, now this right here is our optimization equation. This is our optimization equation, and this is what we want to find. We're going to define some constraints in a second, but this equation is our z. This is what we want to optimize, the return on investment. Okay, so we want to determine values for x and y that maximize the value z. All right, so next we're going to determine our constraints. So let's go ahead and erase this. We should have this all copied by now. Let's actually, let's go ahead and erase this. Okay. So let's go ahead and define some constraints. We know that we want to invest 4 times as much in bonds as in gold. We read that from our problem. So one constraint is going to be x, which x is the amount of money invested in bonds, is going to be greater than or equal to 4y. Y is the amount of money invested in gold, so we want to invest 4 times as much in bonds as in gold, at least 4 times. So this is going to be our first constraint. Now the second, we don't want to invest more than $20,000 in stocks, which is our index fund. So we're going to have the following constraint. The amount of money we're going to invest in our index fund is $100,000 minus x plus y. And this can be either less than or equal to $20,000. We don't want to put more than $20,000 in our index fund. And this is our expression describing our index fund. All right. Since we're going to have 2 more constraints, since we're interested only in investing $0 or more, we can't invest a negative amount of money. We got to include these couple of constraints. Excuse me. So we have x, which is the amount of money invested in bonds, can be either greater than or equal to 0. It can't be negative. And y, which is the amount of money invested in gold, has to be either greater than or equal to 0. It can't be negative. And also, the amount of money invested in our index fund cannot be negative. So we're going to have 100,000 minus x plus y has to be greater than or equal to 0. Okay, so these are our constraints here. So we have our optimization equation, which we'll go ahead and rewrite here. This is our optimization equation. Optimization equation. And this is going to be z equals 12,000 minus 0.09x minus 0.02y. This is our optimization equation, and these are our linear inequalities that define our constraints. So what we're going to do next is let's go ahead and we're going to have to graph this to find the feasibility regions. So let's go ahead and put these in sloped intercept form by solving for y. So this is going to become, if we divide both sides by 4, this will give us y is less than or equal to x over 4. Let's go ahead and convert this into slope-intercept form. This is going to give us y is greater than 80,000 minus x. I'll leave you to do the little work after the video, but if we rearrange this, we'll get y is greater than or equal to 80,000 minus x. These two are already in slope-intercept form. Go ahead and rearrange this one. This one's going to be y is less than or equal to 100,000. Y is less than or equal to 100,000 minus x. And these are a slope-intercept form for our constraints. So we're actually out of time here. So in the next video, we're going to graph these constraints, and we're going to optimize. We're going to find the maximum and minimum values. Actually, we're only worried about the maximum value. So we're going to maximize our optimization equation. So I'll see you in the next video.